Hello everyone, myself Sindhuja. I am studying in Srinivasa Ramanujan Institute of Technology. I am from branch ECE. Now today's my topic on Butterworth and chebyshev filters, and I am selected this topic from the signal system and stochastic process, and the subject code of SSP is 23A04301, and my roll number is 23401A04A7. And let us start the introduction about Butterworth and chebyshev filters for speech signal analysis. And the introduction part: in the field of digital signal processing, the function of a filter is to remove unwanted parts of the signal, such as random noise that is also undesirable, to remove noise from the speech signal transmission, or to extract useful parts of the signal, such as the components lying within a certain frequency range. Filters are broadly used in signal processing and communication systems in applications such as channel equalization, noise reduction, radar, audio processing, speech signal processing, video processing, biomedical signal processing that is noisy, ECG, EEG, EMG signal filtering, electrical circuit analysis, and analysis of economic and financial data. Two types of infinite impulse response filter, namely Butterworth and Chebyshev filters, will be discussed theoretically. The impulse responses, magnitude responses, phase responses for filtering the speech signal will be observed. Analysis of speech signal, its sampling rate and spectrum response will also be performed. IIR filters. Digital filters can be classified into two categories: FIR filter and IIR filter. Analog electronic filters consisting resistors, capacitors, and inductors are normally IIR filters. On the other hand, discrete time filters, usually digital filters based on a tapped delay line that employs no feedback, or essentially FIR filters. IIR filter has certain properties such as width of the pass, pass band, stop band, maximum allowable ripple at pass band, and maximum allowable ripple at stop band. A design of IIR filter can be done with the help of those properties. IIR filters can be usually implemented using structures having feedback recursive structures. The present and the past input samples can be described by the following equation. The equation is that y into m is equals to summation k is equals to 1 to n ak y into m minus k plus summation k equals to 0 to m bk x into m minus k. Let us now see the difference between FIR and IIR filters. The main difference between IIR filters and FIR filters is that an IIR filter is more compact in that it can habitually achieve a prescribed frequency response with a smaller number of coefficients than an FIR filter. An IIR filter can become unstable, whereas an FIR filter is always stable. IIR filters have many advantages as follows. Let us see one by one. Less number of arithmetic operations are required in IIR filter. There are shorter time delays in these filters. IIR filters have similarities with the analog filters. And the fourth one is lesser number of side lobes in the stop band. They are more susceptible to noises. These five are about the IA or filters have many advantages. And we know that the formulas of Butterworth and what is mean by Butterworth filter. Butterworth filter. Let us know what is meant by that. The phase response of the Butterworth filter becomes more non-linear with increasing n. This filter is completely defined mathematically by two parameters. They are cutoff frequency and number of poles. The frequency response of the Butterworth filter is maximally flat in the pass band and rolls off towards zero in the stop band. Butterworth filters have a monotonically varying magnitude function with omega. Unlike other filter types that have non-monotic ripple in the pass band and the stop band, compared with the Chebyshev type 1 filter, the Butterworth filter has a slower roll-off and therefore it will require a higher order to implement a particular stop band specifications. Butterworth filters have a more linear phase response in the pass band than Chebyshev, and magnitude square response of low pass Butterworth filter is given by h into j omega is equals to 1 by 1 plus omega by omega c whole power 2n. Filter selectivity Fs is equals to n by 2 root 2 omega c. Attenuation A equals to 10 log into 1 plus W by Wc whole power 2n. We can see the magnitude response in the presentation of the graph of Butterworth. And Chebyshev type 1 filter, the absolute difference between the ideal and actual frequency response over the entire pass band is minimized by Chebyshev type 1 filter by incorporating equal ripple in the pass band. Stop band response is maximally flat. The transition from pass band to stop band is more rapid than that for Butterworth filter. The ripple is often given in dB. Ripple is equals to 20 log 10 root of 1 plus epsilon square. The magnitude square Chebyshev type 1 response is h into j omega is equals to 1 by 1 plus epsilon square c n square omega by omega p, where cn w by wp is equals to cos n cos inverse w by wp. Magnitude of w is less than or equals to p cos h n cos inverse w by wp, whereas mod of w greater than or equals to wp. The magnitude square response peaks occurs in the pass band when cn is equals to 0. Then we get that h into j omega minimum is equals to 1 by 1 plus epsilon square. Input signal. Following figure shows that spectrum of the input signal, that is the speech signal. The sampling rate of the speech signal is 8000 and the number of bits per sample is 16. And we can observe that low pass Butterworth filter, as the first is impulse response of the LPF, and the second one is magnitude response, and third graph represents magnitude response in dB of LPF, and fourth one graph represents phase response of LPF, and the graph E represents pole zero diagram of LPF, and F graph represents that spectrum of the LPF output signal. And next, high pass Butterworth filter, same as like before low pass Butterworth filter. There are 6 types graphs are present here: impulse response, magnitude response in dB of HPF phase response of HPF pole zero diagram of HPS spectrum of HPS output signal. And here the band pass Butterworth filter and band stop Butterworth filter, and low pass Chebyshev filter 1, high pass Chebyshev filter 1. And conclusion, low pass filters has pure poles, all other filters have complementary zeros, but Butterworth LPF has complex poles. An important property of the Butterworth filter is the gain flatness in the pass band. It has a realistically good phase response but a poor roll off rate. On the other hand, Chebyshev has a better roll off rate because the ripple increases. Chebyshev filters have a poor phase response. The transfer function of a Chebyshev filter is characterized by a number of ripples in the pass band. The sharp transition between pass band and stop band of a Chebyshev filter produces smaller absolute errors as well as faster execution speeds than a Butterworth filter, but it does not provide a good performance for speech signal analysis. The filter order passband and stopband ripple are considered for the design of IIR filter. Thus, it has been found that the Butterworth filter is the best compromise between the attenuation and phase response. It has no ripple in the passband or the stopband. Thank you.